Let's solve some quadratic equations using the square root property. The square root property works perfectly when we have either a variable just squared or we have a quantity involving a variable that's squared, and that's the only place the variable is. So the two problems on this page, I just have a squared variable, right? So I just have a y squared, I just have p squared. I don't have any y terms, there's nothing y to the first, there's nothing p to the first. So both of these problems can be solved using the square root property. The way the square root property works, I want to get the squared thing by itself, and that's what I've got here in the first problem. So it's pretty easy to solve then. I just take the square root of both sides. But when you decide to take the square root of both sides, you have to throw in plus or minus. So the square root of y squared, that sort of just cancels out. I'm left with y. Here I'm going to get the square root of 48. So that would be the solution, the square root of 48. It's just not simplified. And usually we want to try to simplify as much as possible. And so what I look for, you know, is there a perfect square factor of 48? Is there something that goes into 48 that's a perfect square? And of course, you know, some perfect squares, I've got 2 squared is 4. Now that does go into 48. 3 squared is 9, 9 does not. 4 squared is 16, and actually 16 goes into 48 3 times. So I can break this up then as 16 times 3. So square root of 16 times square root of 3. So y would be plus or minus 4 times the square root of 3. And instead, if you'd want to, you could say that the solutions then are negative 4 square root of 3 and positive 4 square root of 3. Okay. In this second problem, my variable is just squared p squared, but it's not isolated. It's not by itself like the y squared was up here. So my first step is going to be to get rid of that 32. So I'm going to add 32 to both sides. And if I do, then I just get p squared equals 32. And again, then I'm going to take the square root. So again, I look for some factors that go in here, and we see that 16 works again. I guess I had 16 on my mind when I was doing these problems. So 16 times 2, square root of 16 is 4. And so my solutions, we have negative 4 square root of 2 and positive 4 square root of 2. Now on these two problems, I don't have just my variable squared, but I have a single quantity, a set of parentheses with my variable in it that's squared. So in this particular situation, I can still use the square root property. So the square root of something squared, that cancels out. I would just be left with x minus 4. Here I have to throw in the plus or minus on the other side. Now, two things have to happen here. The square root of 40, I need to think about if I can simplify that. Is there a perfect square that goes in here? And of course 4 does. And then I'm also going to have to move this 4. It doesn't really matter which one you do first. It doesn't matter. So if I think about simplifying the square root first, I know that 40 is 4 times 10. Now remember, I could also say that 40 is 2 times 20 or 5 times 8. The problem is there are no squares there. There's nothing I can take the square root of, right? I don't know the square root of 2, I don't know the square root of 20, I don't know the square root of 5, I don't know the square root of 8, but I do know the square root of 4. So remember, that's why we pick that. So x minus 4 equals plus or minus the square root of 4 is 2. And now to get my x by itself, I'm going to add 4 to both sides. Remember, we sort of have the idea of like terms, like radicals here. This, what I started with had a square root of 10. There's no square root of 10 here. I can't put the 4 and the 2 together. They're just going to have to both appear in my answer. I'd probably put the 4 first. I mean, if you wanted, you could write it this way. But most people would say 4 plus or minus 2 square root of 10. Again, there's no way of putting these together. So for my solutions, we would have for minus 2 square root of 10 and for plus 2 square root of 10. But you cannot say here 4 minus 2 is 2 or 4 plus 2 is 6. Don't do that. The square root of 10 is multiplied. Multiplication takes priority over addition or subtraction. This last example here, it's sort of similar to what I had in the third one up above. The problem is this squared quantity is not by itself, so I'm going to have to get rid of that 36. So I'm going to start by subtracting 36 from both sides. That's going to leave me 2x minus 1 quantity squared equals negative 36. And then I'm going to take the square root. Now anything we've had before is fair game in these problems. First of all, when I take the square root, I have to put in the plus or minus. Next, notice I have the square root of a negative number. If you have the square root of a negative number, that ends up involving I. So I get I times the square root of 36, and then the square root of 36, of course, is just 6. So I would get I times 6, or I can write that 6I. Now I need to solve for x. I'll add 1 to both sides. So like up here, I can put that 1. Here the 4, I could either put it at the end or in the front. Same thing with this plus 1. I can either put it at the end or in front. Most people put it in front. And then I'm going to have to divide by 2. The whole side gets divided by 2. Now, it's sort of up to you. You can write the problem this way, or you can write it this way. What you can't do is come up here and just cancel the 2 and the 6. You've either got to leave it this way or put both parts over 2 so that, yeah, the 6 divided by 2 is 3, but you still have 1 divided by 2, which is this 1/2. For my solutions then, we could either say, 1 plus 6i over 2 and 1 minus 6i over 2, or I could say 1/2 plus 3i and 1/2 minus 3i. It really doesn't matter too much which way you do that. So those are some examples of using the square root property to solve quadratic equations. The square root property only works well when you have problems that are sort of set up for it, like these 4 examples.